Hi, in this video, we'll try and understand what is distance, displacement, and their relation to speed. What are the various types of velocities? Let us take a point A and a point B. Suppose I want to travel from point A to point B, and this is the path. Then the length of this path when I travel from A to B is the distance covered. It could be meters, centimeters, or whatever units we consider, or kilometers. So typically, the length of the path covered is what we call a distance. So then what is displacement? So if I move from A to B, is displacement the same as distance? No, not necessarily, because displacement refers to how much is the change in position. From position A, I move to position B. Of course, when I talk about a position A and a position B, I am talking with reference to a particular point of origin. So let us try and understand this better. If I say this is my point of origin or a reference point from which I point to other positions and say this is A and this is B, so on and so forth. Then initially if I am at A, this A, then with respect to the point of the origin, I can draw a vector like this and say this is my initial position vector. Let me call it I. This is the initial position vector. And after I traverse this path and reach B, my B can be represented, the point B can be represented by this position vector, which is the final position vector. We can call it as F. So from position A, I move to position B. So I could have traversed it along this path, or I could have gone like this, or whichever way. But then the important thing is my position has changed from A to B, which in vector form we can represent it as initial position vector I and final position vector F. Now by triangle law of addition, we know that if I have a vector I and a vector F like this, then this vector, which we call it as displacement vector, displacement is a vector quantity, is final minus initial, F minus I. This is what is the displacement vector. So the displacement is a vector quantity, which means there is a magnitude and a direction associated with it. If I say I have traveled the distance of 10 meters, then it's just a scalar quantity. I could have traveled it in any way, any direction. But when I say my displacement is 10 meters, it always, is it in this direction or is it in this direction or here, it could be anything. So this is the difference between distance and displacement. Displacement is a vector quantity. Now these give rise to the other two terms, which are connected to the other two terms, which is speed and velocity. Speed is nothing but distance over unit time. Distance by time. The unit is meters per second. So how much distance have I covered and how much time did I take? Obviously, if I had covered this 10 meters in 2 seconds and this 10 meters in 5 seconds, I am faster in the first instance. So my speed is more. But is velocity the same as speed? No, not necessarily. Velocity is a vector quantity. Velocity is displacement over time. So how much have I changed my position over time? That is velocity. In fact, to be specific, we need to understand two types of velocity here. Two ways it is described. Let's say I move from point A to point B. Now, if I go from point A to point B in this direction, and then I come back this way, I go this way and come back this way, has my displacement or position changed? No. So we can say that the displacement is zero. Displacement is zero. There is no displacement at all. But then I've been moving at a particular speed all the while. I moved from A to B, and via B I came back all the way to A. So I have been moving at a particular speed. So definitely there is a speed. But since velocity is displacement over time, it becomes zero. So the speed, let's say if I traverse this distance, whole distance is 20 meters in 5 seconds, then speed be 20 by 5. This is 4 meter per second is the speed, but not any particular direction because it's a scalar quantity. But when I look at displacement from initial position is at A, final position is also at A, then the displacement is zero. So can I say velocity is zero? Yes, but that is called the average velocity. Average velocity will be zero. So because there is always a velocity all when this object is moving, because whenever you talk about speed, you cannot tell it's moving without any direction. I mean, there is always a direction associated with each instance. Suppose let's say if I take this particular position, let me mark some positions here. I have 3 x's marked here. At this point, if I take the velocity at that particular instant, let me call this 1, 2, and 3. At instant 1, definitely the object has a velocity because it is moving in a particular with a particular speed in a particular direction. At 2, there is a definite velocity at that instant. And then at 3, there is a velocity at that instant. But what happens when it goes all the way from A to B and back to A? The average of all these velocities becomes 0. So the average velocity is 0. But then instantaneous velocity at particular instances is not 0. So there is a instantaneous velocity. So intuitively, if you see, there are a lot of vectors here, 1, 2, 3. And then when it comes back, obviously there will be vectors in the opposite direction also at every instant. All this will average out to be 0. And net you can say the object has not been displaced. So the average velocity over this particular travel, over this particular time period is 0. But then there have been lot of instantaneous velocities along the path. At lot of each position there has been a velocity. Those are called instantaneous velocities. We will discuss more about average velocity and instantaneous velocity in the subsequent videos. Thank you.